This video covers section 9.1, square roots. Objective 2, determine whether a square root is irrational, rational, or not a real number. So remember from the practice problem, number 2, rational numbers are numbers that look like 4, 8/2, 5/7, and decimals, 0.5, 0.75. Irrational numbers are going to be numbers like square root of 2, square root 3, square root 5, square root 7, square root 6. So we started this section by looking at the perfect squares and their square roots in the practice problems. If we take a square root of a number that is not a perfect square, we get an irrational number. For example, square root of 25 is 5. So this radicand, the number underneath the radical, is a perfect square. And so we say that square root of 25, or 5, we say this is a rational number. But if the radicand is not a perfect square, it's irrational because we don't have a rational number whose square is 20. The radicand is a non-perfect square. In this case, we do one of two things. We either just write the decimal approximation of the radical by using a calculator. It's about 4.4. Or in section 9.4, we will simplify the radical using properties of radicals. So for example 3, we're just going to estimate this square root to sit between its two nearest whole numbers. And from that, we can get a decent decimal approximation. So I want to locate the square root of 90 between two whole numbers. And if 90 lies to the right of 81, 9 times 9, and to the left of 100, 10 times 10, then the square root of 90 is smaller than 10 and bigger than 9. And so we'll say that the square root of 90 is bigger than 9 and smaller than 10. And from this, we could estimate the square root of 90 to be, well, about halfway between 9 and 10. And so we might say 9.4, 9.5, and that's a pretty decent decimal approximation from eyeballing it. If we do the square root of 350, this one's a little bit harder because we need to get this between two perfect squares. So we have 350 is definitely smaller than 400, which is 20 on this side. And then 19 times 19 on the other side is 361. And so that would be on the right side, and on the left side should be 18. $324. So we've located 350 to be smaller than 361, bigger than 324, which makes the square root of 350 smaller than 19 and bigger than 18. So this sits between 18 and 19. But if we wanted a decent decimal approximation, we'd say that 350 to 361 is 11 away. 324 to 350 is 26 away, so it's closer to 19, so we might say 18.6, 18.7. And that's how you estimate these, by eyeballing them. So this leads me to your practice problem. I encourage you to press pause in your video and work these out, and come back when you're ready to see the solution. Square root of 200. Now that you've had a chance to work this out, I'll show you how I would do this. $200. We know that's smaller than 225, which is 15. And then the other side is 14 times 14. Or 196. So square root of 200 lies between 14 and 15. And 196 is much closer to 200 than 225 is. So we would say it's about 14.1, 14.2. And then the square root of 280. We have 15 squared is 225. 16 squared is 256. 17 squared, 289. So we've got it located between 225 and 289. 15, sorry, not 225, 256 and 289. So in between 16 and 17. And 280 is much closer to 289 than it is 256, so we might say 16.7. Okay, so we see that these are examples of irrational numbers because the radicand is not a perfect square. But what if you have the square root of a negative number? We're asking what real number can you square and get negative 16? And we know that anytime you square a number, you end up being non-negative. So there is no real number whose square is negative 16. So we conclude that negative numbers do not have square roots that are real numbers. So the properties of square roots, the square root of a perfect square is rational. The square root of a positive rational number that's not a perfect square is an irrational number like square root of 20. And now we add the square root of a negative real number is not a real number, so the square root of negative 2 is not a real number. So now we have three types of radicals going on here. Letter A, non-perfect square? Letter B, we have a perfect square. Letter C, we have a negative number. And letter D, we have a negative on the outside of the radical, and then you have a perfect square underneath. So this problem is for you to try. I encourage you to label these as to what you think they are, and then come back when you're ready to see the solution. Now that you've had a chance to label these, the square root of 31 is a non-perfect square, so we'll label this one as irrational. Letter B, the square root of 169 is 13, and so that one's rational. Letter C, negatives underneath the radicals are not real. And letter D, the opposite of the square root of 81 is the opposite of 9, or negative 9. And so that's a rational number. This concludes the video for section 9.1, square roots. Objective 2, determine whether a square root is rational, irrational, or not a real number.